Okay, so thanks everyone for listening in today. The work I'm going to talk about today goes back to early 2019 when two tropical cyclones impacted Mozambique within the space of just a few weeks. This was the first time two tropical cyclones had made landfall in Mozambique during one cyclone season, let alone a few weeks. And during these events, a team from universities of Reading and Bristol, alongside ECNWF, provided emergency flood bulletins to the UK government, which were designed to aid decision-making in the international humanitarian efforts. So today I'm just going to give a brief overview of the work of this large team of scientists across several disciplines, some of whom are chairing the session, and I think I've listening in today as well, to evaluate all the different aspects of these flood bulletins. So while I won't have time to go into detail on all of the findings of this work, I hope it will give you an overview of the forecast chain evaluation that we did. And if you want to find out more about the cyclones and the bulletins and our methods in more detail, we recently published a paper, which I would encourage you to take a look at if you're interested in those aspects of the work. So to give a bit of background to the events, in March 2019, Cyclone Idai hit central Mozambique twice. First as a fairly weak storm, but with enough rainfall to cause flooding in both Mozambique and Malawi. And then again as a second, as a strong tropical cyclone after looping back around over the Mozambique Channel, where it intensified and headed back towards the same stretch of coastline. Idai affected more than 3 million people, killed 1,000, and further led to an outbreak of cholera. And then just a few weeks later, Cyclone Kenneth impacted northern Mozambique as the strongest cyclone to reach Mozambique in recorded history. And this also resulted in severe flooding, 45 further fatalities, and the destruction of thousands of homes. So shortly after Idai made landfall, the president of Mozambique declared a state of emergency and requested international assistance. It was at this point that the UK government's Department for International Development, DFID, which incidentally now is the Foreign Commonwealth and Development Office, FCDO, they tasked a team of scientists working on various related SHIR projects to support their humanitarian efforts with flood forecast bulletins. The SHIR is the UK's Science for Humanitarian Emergencies and Resilience programme, and this is partly funded by DFID. So they were aware of the projects working on research closely related to both flooding and tropical cyclones, including FATHOM, which is Forecast for Anticipatory Humanitarian Action, led by Liz Stevens at Reading, PIXI, which was the Predicting the Impacts of Cyclones in Southeast Africa project, also at Reading, and HIWeather, which looked at high resolution flood mapping and is based at the University of Bristol. So several researchers from the three SHIR projects also worked really closely with the team at ECNWF who work on GLOFASS, the Global Flood Awareness System, which is a Copernicus emergency management service providing global flood forecasts. So after Cyclone Idai made landfall and DFID got in touch, the team at the University of Reading, with the support of ECNWF, used ECNWF's meteorological forecasts and the GLOFASS flood forecasts to summarise the flood hazard from the cyclone, including where the cyclone would move, how much rain was expected, when rivers would flood, and when the flooding was likely to recede. The team at the University of Bristol then used the forecast data from GLOFASS to undertake detailed flood inundation estimation and impact risk assessments to produce estimates of how many people were at risk of flooding. So these two reports were compiled together into a final document, which was sent out to DFID. They were able to then provide feedback to us and ask for any clarifications that were needed before sharing the bulletins more widely, for example, with the United Nations Office for the Coordination of Humanitarian Affairs, the UN OCHA. And we were also able to share them directly with our humanitarian research partners. They were then intended to be used for decision-making as supplementary information alongside forecasts from the National Meteorological and Hydrological Services out in Mozambique. And then when it became clear that a second cyclone, Cyclone Kenneth, was forming and was likely to move towards Mozambique, the UN OCHA and DFID requested a reactivation of the bulletins, and we were able to begin producing them ahead of Cyclone Kenneth's landfall in northern Mozambique. So following the two cyclones, we evaluated the various different aspects of the forecast used in the bulletins, from the cyclone tracks down to the usefulness of the bulletins themselves. So over the next few minutes, I'm going to give a brief overview of each of these elements for Cyclone Idai only in the interest of time. And there's a more detailed summary, including the methods and the same work for Cyclone Kenneth, which can be found in the paper. So I should say this work is based on a retrospective analysis of the forecasts. So while we began producing the bulletins shortly after the state of emergency was declared on the 19th of March, we've looked back to see how well the forecasts performed for the whole storm. So the first element in the chain for these bulletins was the track forecasts, which come from ECMWF's ensemble, and were used to provide information on where the cyclone was likely to move. So this evaluation of the raw forecast data, including before the storm had formed and the official products are produced, this showed that ECMWF's forecasting system began to consistently indicate the potential development of a tropical system in the Mozambique Channel from the 26th of February, which is about 3 days before the storm even began to form, although it's of course not possible to know exactly where the storm will impact at this stage. So the storm made its first landfall on the 4th of March, and then remained over land until the 9th of March, when it moved back out over the channel. From the 6th of March, so when it was still over land as a fairly weak storm, and 9 days ahead, the forecast already showed a high probability that the storm would make a loop over the channel and impact Mozambique a second time. Although at that point, 9 days ahead, the point of location of the second landfall was still very uncertain. We just had an indication that this looping situation was likely. So on the 10th of March, the storm intensified and became very strong, having moved back out over the warm waters of the channel. And it was at this point that the forecasts of the landfall location became much more certain, about 5 days ahead. And this is the forecast that's showed on the top right in the images shown on this slide. So on average, across all the forecasts of the cyclone tracks produced for Cyclone Idai, the errors at 1 day ahead were approximately 75 kilometers, and at 3 days ahead, 200 kilometers. After 5 days ahead, the skill deteriorates rapidly, with large errors of up to 1,000 kilometers at 7 days ahead. And this is due to the uncertainty and difficulty associated with predicting such a meandering and looping track as we saw with Cyclone Idai. At shorter lead times, the errors for Idai are comparable with the average errors of ECMWF's forecasting system in this region, based on forecasts of 35 recent storms in the region. So the next element in the chain is the rainfall forecasts. And the figures here show the total rainfall observed throughout the duration of the storm. On the top left, based on the GPM emerged satellite data. And then on the bottom left is the ECMWF's high resolution deterministic forecast rainfall totals for the entire storm, based on forecasts produced 1 day ahead. The bottom right shows the difference between the observed satellite rainfall and the forecast rainfall. So red indicates where the forecast underestimated the amount of rainfall, and blue shows an overestimation of the rainfall. Typically, for Cyclone Idai, ECMWF forecasts overestimated rainfall totals across much of central Mozambique, particularly at this lead time, and underestimated rainfall in northern Mozambique and over the channel. With increasing lead times beyond 1 day ahead, the forecast tended to underpredict the rainfall over central Mozambique and overpredict in western Mozambique. This evaluation shows how key the track forecasts are for correctly predicting the rainfall, as these errors that we're seeing in the rainfall can be tied to the forecast of the cyclone's track, which predicted the storm to continue moving west, rather than the observed stalling of the storm over central Mozambique, where it sat for much longer than anticipated, resulting in large amounts of rainfall in central Mozambique. And this is what led to the overestimation of rainfall in the west in the forecasts, because the storm didn't move as far inland as expected. And this stalling of the storm was only picked up at very short lead times, I think, up to 1 day ahead at maximum. So next we come to the flood forecasting. The Global Flood Awareness System, GLOFAS, uses ECMWF's ensemble forecast to drive a river routing model to produce forecasts of river flooding out to 30 days ahead. So the figure produced here by Andrea Ficky shows the maximum probability of flooding in some of the major rivers that were affected by Cyclone Idai for each of the daily forecasts produced throughout the event. From 1st of March, which was the day the cyclone formed, GLOFAS forecast indicated a 10 to 20% probability of severe flooding in the region. The predicted peak of the flooding from Idai's first landfall as a weak storm was around the 9th to 10th of March, which is consistent with the post-event reports from the Hydrological Service. As the storm made landfall and therefore uncertainty around the landfall location was eliminated, the probabilities of severe flooding across the region for the 5th of March onwards increased to more than 80%. For the second landfall is a stronger storm forecast from around the 10th of March, which again coincides with the intensification of the storm over the channel and the increased confidence in the track and rainfall forecasts. This is when the forecast began to indicate a second flood event that would peak around the 18th to the 20th of March. Again, in terms of the flood forecast, the late prediction of the cyclone stalling over central Mozambique is also reflected in the uncertainty in these. And this can be seen in this figure by the drop in probabilities for the forecast around the 13th to 15th of March. And you can see that the probabilities greatly increased again once the stalling was picked up in the track forecast around the 16th. So overall, for the flood forecast, the locations and the rivers affected by flooding were correctly predicted by GLOFASS, in some cases with up to a 10-day lead time. But for severe flooding, the probabilities remained fairly low until around the 9th of March, with quite large uncertainties in the expected timing of the flood peaks. So the next step in the chain is then, of course, the estimates of the population exposed to flooding, which were included in the bulletin from the University of Bristol. These estimates began to highlight the potential severity of the event from the 4th of March onwards. But at this point, the estimates were very uncertain, with the most affected areas predicted to be much closer to the border with Malawi than was eventually observed. As time progressed and the forecast became more certain, the estimates of the most affected areas shifted. For location became more certain in the meteorological forecasts. So comparison of these exposure estimates with post-disaster reports is really challenging. These reports typically give the total number of affected people, while the bulletins that we were writing provided estimates of the number of people affected only by river flooding, rather than other or all aspects of the cyclone. According to a UN OCHA situation report, I think around 198,000 houses were reported to be destroyed by the cyclone. And while many of those may well have been due to flooding, it's not possible to say whether this was the sole or the primary cause. So the bulletins estimated that the total population likely to be affected by severe flooding from Idai was around 200,000 people. An assessment that came out of 14 districts across the region later estimated the total affected population was around 1 million, which was right at the upper end of the estimates from our models. However, the authors of that assessment do state that it's possible there was some misunderstanding around the terminology used in Portuguese, and suggested that there was a potential overestimation of the people flooded. And this really goes to highlight the complexities involved in comparing these exposure estimates with the post-disaster assessments that are often available from these events. So in the paper, we've also actually included a little bit more analysis than for Idai for the exposure estimates, as we were able to access a report that detailed the total number of people affected in each district, which allowed a more direct comparison with our estimates, although not without its challenges, as the definition of affected in those reports also covers factors such as extreme winds, food insecurity, previous heavy rains from past events, and more, which we weren't able to account for in our models. And so finally in this chain, we asked, were the emergency flood bulletins useful? And by this, we mean to what extent can we be sure those receiving them were able to take better decisions based on the information, or whether they were just an addition to the overload of information for the actors involved on the ground and distracting from priorities? So to review the use and the usefulness of the bulletins, we used evidence from reports, emails, and also interviews, conversations, and some written commentary from post-event meetings that we held in Mozambique in September last year, with representatives from government agencies, including the National Meteorological and Hydrological Services and the Disaster Management Authority, and also the Red Cross and academics from the Technical University of Mozambique. So feedback from DFID was that this was the first time they had been able to use science so early in planning for and responding to cyclones, and that the bulletins were generally well received. Our international humanitarian partners also noted this was the first time that flood risk and impact information had been provided to them in real time. And this combination of meteorological, flood hazard and impact information was valuable and promising for future. One point was that the dissemination of this information through these high-level international organisations such as DFID and the UN OCHA meant that the information was in fact able to reach a wide range of decision makers at both international and local levels. And then through project collaborations, we were also able to share the bulletins directly with our research partners in Mozambique, which gave the opportunity for decision makers to ask questions directly to those producing the bulletins in real time. And their feedback was also incredibly useful for the team writing the bulletins. It allowed us to refine our methodology and the format with each new bulletin produced. So while the information was well received and it was disseminated widely, it's challenging to find out how this type of information directly informed decision making. And I believe Linda will be talking about this aspect of the challenges and what can be learned from post-event reviews a bit more in the next session. Here, I just wanted to highlight that it's not always easy for organisations to articulate how the bulletins were helpful or were used. In these emergency situations, decision makers are of course required to consider numerous and varying pieces of information and to make a balanced decision. So a specific contribution from one piece of information to such a complex decision is quite difficult to convey. The bulletins were in fact just one piece of information amidst this whole array of other types of information within a much wider system. And while some organisations incorporated the information into existing products such as their situation reports, for others this might have been the first time they'd received this particular type of real-time information and not quite known how to use it in such an emergency situation. It's also, of course, really challenging to know whether the use of the bulletins enabled better decisions than if the information hadn't been available at all. So while the feedback indicates that a key contribution of the bulletins was to assist in creating an overview of the situation, so where and when flooding was likely to occur, where there were most people at risk and when the floods would recede. And this was best done using a whole range of information from both the bulletins and also other sources of local data, forecasts and information. Through DFID, we learned that the bulletins did enable decision makers to have a better understanding of the flood risk and to move people and equipment and release supplies into the areas that were at greater risk, allowing a slightly earlier response than would have been possible without this information. As just so finally, to kind of wrap up, in the paper we go into a lot more detail about the challenges of producing these bulletins and the lessons learned through the production and through the post-event discussions. So if you're interested in this aspect of the challenges and lessons learned, I'd encourage you to take a read of that section of the paper, and you're always welcome to email if you have any questions on that. Sadly, I don't have time to go into any detail today, so I've just put up on this final slide a list of the key recommendations that came out of this work for the provision of such information for future events. This is focused around kind of key themes of co-production and the embedding of social science knowledge, operationalization of this kind of information, and effective forecast communication. So to conclude, while there is the potential to use these large-scale forecasting systems to support the international humanitarian community, to better support early humanitarian action with the best science and to better integrate information produced both nationally and internationally, we need more collaboration between the forecast producers, the intermediaries, and the users. So I think I've rather ambitiously tried to squeeze a lot of information into this talk, so I'll leave it there and I'll leave this slide up for a few minutes, and I'm happy to answer any questions if we have time or in the chat.
Thank you very much, Rebecca, and I hand over to Helen for the questions.
Yeah, that's great. Thank you, Rebecca, for a fantastic talk. There's a question from Brian Golding in the chat. Would you like to ask it in person, Brian? You might need to unmute yourself, Brian.
Yes, it just takes a little time to get through. I wondered how the relationship with the local weather service went and whether there was any conflict between your advice and theirs.
Yeah, so that's one of the key kind of challenges and recommendations that come out through this work. We're lucky that particularly through the Pixie project that I worked on for a couple of years, one of our research partners on our advisory board was a director at the National Meteorological Service, so they were aware that we were producing this information. Unfortunately, because it was produced, in this emergency situation, we weren't able to fully collaborate as much as we would have liked. We did try and take into account forecast information from the national services in the regions wherever we could in the bulletins to make sure that it was coherent. So the Met Service, they get their tropical cyclone track and intensity forecasts often from the La Reunion regional Met Centre, and we also were looking at those forecasts to kind of make sure getting information between what we were saying and what the official warnings were. And we did receive some information through our Red Cross partners that had come from the Hydrological Service, which were able to inform our reports. So there was some relationship there and some collaboration, but it was nowhere near as much as we would have liked and would be preferable in the future.
Thank you.